Hi, I'm Naim and welcome to the very first video on Math Icon Institute. In today's session, we are going to break down indices in a way that's clear, simple, and exam focused. So grab your pen and let's get right into it. So what is indices? Let's start with this. Indices is the plural form of index. Without index. Index is singular. While indices is the plural. And what is an index? When you say an index, it simply means the number of times you multiply a number by itself. An index is the number of times you multiply a number by itself. For example, if I write 2 is power 3, this simply means 2 times 2 times 2. You can see 3 here. 3 here is the index. And what does that mean? It means I'm multiplying 2 itself 3 times. So the number of times I'm multiplying 2 itself is the index. So I say 2 is power 3, 3 there is the index. Now, if you have form is now indices, that's index in simple terms. But when I say also 10 raised to power 4, that simply means 10 times 4 times 10 rather times 10 times 10. 10 raised to power 4. I'm multiplying 10 by itself 4 times. So we say 4 is the index. That is simply what index means. And then this number I wrote here, 10 raised to power 4, that's two parts. But that's the base. 10 is the base. 10 is the base, and then 4 is the index. 4 is the index. So we can write any number in its index form this way. For example, I have 2 is power 0. 0 is the index, while 2 is the base. So each number has an index and a base. Even if I write 4, for example, you might be wondering, 4 does not have an index. No, it has an index. Here, 1 is the index. 1 is the index. If you write any number without an index on it, just know that 1 is the index. So any number is the what? Is in its index form. Its index form. And then so there are laws governing addition, subtraction, multiplication, and division of numbers in the index form. So we call them laws of indices. We have laws of indices. And there are a number of them. So the first one is when we have s is power a times s is power b. That's the very first one. And multiplying two numbers in the index form. But now what can we notice there? We can notice that they have the same base. X and X. They are the same base. They have the same base, but they have different indices. The indices might be the same. That does not confirm that. But then they have the same base. X and X. So what happens is this is simply X raised to power A plus B as the product of indices. They are multiplying two numbers in the index form and they have the same base. We simply write one of the numbers here. You have X. Then next to power, you add the indices A plus B. A numerical example here is if we have 2 raised to power 3 times 2 raised to power 5. We can see I'm multiplying two numbers in the index form. And then they have the same base, 2, 2. This is the base, this is the base. This becomes 2 raised to power 3 plus 5. And that is 2 raised to power 8. That is simply what the first law is about. Also, if I have 10 raised to power minus 1 times 10 raised to power 1 over 3. I note that the index might be a fraction, might be an whole number, might be a negative number. As you can see here, 10 raised to power minus 1 times 10 raised to power 12 times 10 raised to power 1 over 2. So we simply have 10 raised to power minus 1 plus 1 over 2. Because they have the same base, 10, 10. So that's 10. Then you add this. LCM is 2. 2 divided by 1, 2 times 1. 2 times minus 1, minus 2. 2 divided by 2, 1 times 1, 1. Then we have 10 raised to power minus 1 over 2. Would the index can be a negative number, a positive number, or even a fraction? That's the first law. The second law, if you are dividing numbers in the index form, type x is power a divided by x raised power b. This is telling us that if you are dividing two numbers in their index form, and then you have the same base, those are the first law, they have the same base. Here also they have the same base. So what do? You simply write one of the numbers, then you subtract their indices. X raised power a minus b. For multiplication, we have the indices a plus b. For division, you subtract them, a minus b. A numerical example is where we have 5 raised power 7 divided by 5 raised power 2. You can see the condition is met. They have the same base, 5, 5, the b. So it becomes 5 raised power 7 minus 2, and that's 5 raised power 5. Another example is where we have 7 raised to power 3 over 2 divided by 7 raised to power minus 1 over 2. The condition is that it should have the same base, and you can see that they have the same base. What do? We simply take one of the bases, that's 7, and we subtract the indices because we are dividing. We minus the indices. 7 raised to power 3 over 2 minus 1 over 2. Now, most students make mistakes when you get to this point. What is that mistake? You see them, they will write 3 minus 3 over 2 minus 1 over 2. That's wrong. This is wrong because when we look at this carefully, we see that this is 3 over 2, right? 3 over 2. Then we said when we have to divide, what do? We subtract the indices, and then you have this minus. That's like you have here minus. Now the second power here has minus. It has its own negative sign. So that's the second minus here. If you write just one minus, you are wrong, because the fact that you are dividing means you have a minus here first, and then the second index has a minus on its own. That minus has to be there also. So you have to include the two negative signs, and then you can now simplify. Result becomes 7 raised to power 3 over 2 minus and minus plus 1 over 2. Then because 7 raised to power, since they have the same correlators, you can just add the numerators 3 plus 1 over 2. That is 7 raised to power 4 over 2. 2 in 4 is 2. That's 7 raised to power 2, and that's 49. That's the second law of indices. And the third law is x raised to power a raised to power b. This law is simply is when you have a number in its index form. That number in its index form, I always say number in its index form simply means a number that has a power. 2 is power 3 is in index form. 4 is power 5. 7 is power 10. They are in the index form. Now, this number x raised to power a in its index form is now raised by another power, which is what? B. A number in index form x raised to power a raised by another power, which is b. To simplify it, what do? You simply multiply those two indices. Multiply this by this. A times b, ab. The numerical example of this is we have 2 raised to power 2 raised to power 3. What do? You simply 2 raised to power 2 times 3, and that's 2 raised to power 6. That example is if we have 3 raised to power 2 over 3 raised to power minus 3. Remember, I said the index can be a negative number or even a fraction, as you can see here. This simply becomes 3 raised to power 2 over 3 times minus 3. That equals 3 cancelled out, then 3 raised to power minus 2. And that's 3 raised to power minus 2. And that's 1 over 9. Okay, or let's do it this way. 3 raised to power minus 2. That becomes 1 over 3 square. And I think there's another law that actually explain this better. 1 over 3 square. 3 square is 9, 1 over 9. So don't worry, there's a law also that will explain this better. This final point. Here's by minus 2. How it became 1 over 3 square. There's a law here that will explain that also. When you get there, we discuss it extensively. The fourth one is x is power 0 equals 1. Where there's a condition here where x is not equals 0. X is power 0 equals 1 where x is not equals 0. That is when you raise any number When you get any number to 0, what happens? The result is 1. 2 raised power 0 is 1. Even if it's a negative number, minus 3 raised power 0 is 1. Even if it's a fraction, 1 over 5 raised power 0 is 1. Any number raised power 0 is 1. Now there's a condition there where x is not equal to 0. That is, that number must not be 0. So that means 0 raised power 0 is not what? Is not 0. 0 raised power 0 is indeterminate. Yes, it is indeterminate. That is, it does not have a value. So take notes, x raised power 0 equals 1. The condition is that x is not equal to what? X is not equal to 0. That's the fourth law. Any number raised power 0 is 1. The fifth law is f raised power minus a equals 1 over f raised power a. And you can see this is very similar to what we saw a few minutes ago. Let me add 3 raised power minus 2. That's when you have a number with a negative index. A number with a negative index, as you can see, minus a is a negative index. How do you go about it? You simply write 1 over, then you move that negative sign. 1 over f raised power a. If I have 3 raised power minus 2 like we saw the other time, it becomes what? 1 over, then you move that negative sign. 1 over 3 raised power 2. That's how we simplify it. So then that's 1 over 9. If I have 4 raised power minus 3, what do you do? 1 over, then you simply remove that negative sign. Then you have what? 4 raised power 3. There's 1 over 64. That's the fifth law. Then the sixth one is when you have f raised power a over b, that is a number with a fractional index. No, the fifth one is a number with a negative index. Here, a number with a fractional index. What happens if you have a number with a fractional index? It simply becomes x raised to power a, the bth root of x raised to power a, or the bth root of x to the power of a. This simply means if we have a number with a fractional index, and now we know that a fraction has two parts, numerator and denominator. The numerator becomes a whole number power. And we know what a whole number is. The numerator becomes a whole number power. While the denominator becomes root. It becomes what? Root. As you can see, a here is the numerator. Fraction a over b. A is the numerator. The number at the top is the numerator. While the one at the bottom is the denominator in a fraction. The one at the top becomes a whole number power. You can see f raised power a. While the one at the bottom now becomes root, depending on what? On the number. If it is 2, it will be square root. If it is 3, it will be cube root. You can see now b root of what? S is power a. Or you can try to change this. Now b root is outside. You can try to bring b root inside and then the power a outside. And that's the second one here. You don't want it to become clearer when we have another example on that. An example is when we have 8 is to power 2 over 3. Yes, number with a fractional index. So in this case, if you said 2 is the numerator here, what happens is it becomes a whole number power at 8 is power 2 because of whole number power. Why the denominator, which is 3 in this case, becomes what? It becomes root. That's cube root. It becomes the what? A fractional power. That's, you can see cube root. Or the other way of writing is the same, the cube root of 8 and then square. That is, we are taking this square outside of that cube root. So either of these two is correct. So if you take this method now, 8 square is what? 64. That means the cube root of 64. So and then this means cube root of 8 square. Now what does square root, cube root and like means? Square root of number simply means how many number. Square root of a number simply means what other number you multiply by itself to give that number. For example, if I say the square root of 4, simply means what number you multiply by itself twice to give 4, and that's 2. 2 times 2. Other we say what's 2. but 2 times 2 is 4. You multiply 2 by itself twice, give 4. 12 of 4 is 2. Cube root, for example, of 8 is 2. Why? Because 2 times 2 times 2 is 8. And the cube root of a number is what? A number you would multiply by itself 3 times to give that number. Now, you see that you multiply 2 by itself 3 times to give 8. So the cube root of 8 is what? Is 2. 64, you multiply 4 by itself 3 times. 4 times 4, 16 times 4, 64. 2. You multiply 4 by itself 3 times to give 64. That means the cube root of 64 is what? Is 4. That's the meaning of cube root. The number you multiply by itself 3 times to give that number. So this is 4. You take this method also. Cube root of it is 2. Then remember there's a square here. 2 square. And that's also what? That's also 4. That's simply what this law is telling us. We have a number, the fractional index, the numerator becomes a whole number power, while the denominator becomes what? Becomes a root. Let's see another example. And another example on that is you have 125 which is about 2 over 3. So this becomes 125. Cube root of 125. 3 is the denominator. It becomes the root. Cube root of 125. Then 2 is the numerator. It becomes squared. And that's simply. This means how many number? This means which number would you multiply by itself 3 times to give 125? That's the meaning of cube root of 125. Which number you multiply by itself 3 times to give 125? And that's 5. You see that 5 times 5 times 5 is 25. So cube root of 125 is 5. 5 squared. That's simply 25. So with that, you can simplify numbers with fractional indices. Now, I want to try to combine the 5th and the 6th law. Yes. What do I mean by that? Take this out. 125 raised to the power minus 2 over 3. Can see you have this is a negative power, at the same time a fractional power. Now when we see power and index are the same, power index are the same. Okay. So you can see minus 2 over 3 is a negative power, so also a fractional power, meaning we've combined the 5th and the 6th law. The 5th law is meant for negative power, while this one is meant for what? The 6th law is meant for fractional power. So we have the 2 here, minus 2 over 3. What do we do? Anytime you have case like this, I would advise you eliminate the negative sign before you proceed. Eliminate what? Negative sign before you proceed. That means try to apply law 5 first, the 5th one. When we have that, if you have a negative power, 4 happens, simply becomes 1 over, then that number without that negative sign. Yes, so we apply that here, it becomes 1 over 125 is power 2 over 3. This will ease your work. Yes. Trying to eliminate the negative sign is your work. 1 over 125 is power 2 over 3. Then this becomes 1 over cube root of 125 square. And that's 1 over 5 square, 1 over 25. One example on that. We have 64 is power minus 1 over 3. This is simply 1 over 64 is power 1 over 3. Right? When you use the negative sign, that will be 1 over 64 is power 1 over 3. And then this now becomes 1 over the cube root of 64. Now you might say, why didn't I include the numerator there, 1 as a power? Yes, 1 is there, obviously. So 1 is there, obviously. So then this is equals 1 over cube root of 64 means the number you would multiply by itself, that is to give 64, and that is 4. 4 times 4 times 4, 64. 1 over 4. And that after that. We move to the next law we have here. That's the 7th one. And then this is useful when you want to multiply numbers in index form. When I try to pay attention to this carefully, we see that in this case, these two numbers, they are a is per x and b is per x. They have different bases, but they have the same indices. You can see x, x, the same index, same indices but different bases. This simply becomes a times b is per x. A times b is per x. And example is you have 2 is per 3 times 5 is per 3. It's simply 2 times 5 is to power 3. And that's what? 10 is to power 3. Let's try confirming if it's correct. 2 is power 3 is 8. 8 is power 3 is 125. So is it really equal to 10 is to power 3? 10 is power 3 is 10 times 10 times 10. That's 1000. Let's confirm if 8 times 125 equals 1000. So 8 times 125, as you can see, is what? 1000. So you can see. So if we have 3 is power 4 times 2 is to power 4, simply becomes what? 3 times 2 is to power 4. And that's what? 6 is to power 4. Then the eighth law we have here is very similar to this, except that the sign you have here is the division sign. A is per x divided by b is per x. You can see also this means we have two numbers. We are dividing two numbers in the index form. They are different bases but the same indices. This is simply equal to a over b all raised per x. Just like you can see for the multiplication, it is what? A times b all raised per x. Here it is what? A divided by b all raised per x. Then in another you have 2 square over 4 square. This is a division sign. So then it comes what? 2 over 4 all this power 2. And then mind you, the power here can also be a fractional power. It can be what? It can be a fractional power. It can be 2 is power 1 over 2 over 4 is power 1 over 2. That's what? 2 over 4 all is power 1 over 2. Notice they have the same power. Then just put the two numbers, which is a division 2 over 4, which is multiplication 2 times 4, then the power outside. Then I forgot to say something regarding fractional powers. Roots are fractional powers. Yes, the square root of 4 simply means what? It simply means 4 raised by 1 over 2. Roots are fractional powers. If I say cube root of 8 simply means what? 8 is power 1 over 3. So which are fractional power? Generally, nth root of x. Nth root of what? X is what? F is power 1 over n. That is just simply take this n that is here. Note that 2 is here, but then we do not write it there for square. For square root, the 2 is there, or the 2 is usually omitted for square root. It's usually omitted. So, but for cube root and higher powers, you can see 3 there, you can see 4 there. So, if you have the fourth root of x, simply means what? F is power 1 over 4. Yes. So let's now take few examples where we would actually combine one or more of those laws in our solution. So simplify the following. First example here. So we have 9 is power 1 over 6 times 9 is power 1 over 2. Writing the first law to simplify this. Since we are multiplying and then they have the same basis, 9 and 9 is the base. It is simply equal to 9 is to power 1 over 6 plus 1 over 3. That equals, find the LCM. LCM is 6. 6 divided by 6, 1 times 1, 1 plus 6 divided by 3, 2 times 1, 2. That is equals 9 is about 3 over 6. Then 3 in 6 is 2. 9 is about 1 over 2. And 9 raised to power 1 over 2 can be simplified further. Remember we said fractional indices are their roots. 9 raised to power 1 over 2 simply means square root of 9. And that's what? That's the. Then the second question. 16 is power 1 over 4 times 16 is power minus 1 over 2. You know, so we apply the first law. That's 16. Then we see basis now. So now 16 is power 1 over 4. Then plus, since we are adding, but it's m times minus 1 over 2. You can see the power is minus 1 over 2. That becomes 16 is power 1 over 4. First time minus is minus 1 over 2. That's 16 is to power. Let's say my core and 3 is 4. 4 divided by 4. 1 times 1, 1 minus 4 divided by 2, 1. 4 divided by 2, 2 other times 1, 2. Now equals 16 is equal to 1 minus 2 is minus 1 over 4. And you can simplify this further. So you can see that you have a negative fractional power here. We would apply law of 5 and 6. So let's remove negative sign cos. That becomes 1 over 16 is power 1 over 4. Now for the fractional power, you come to what? The 4th root of 16. As we say, the fractional power simply means what? 4th root of what? Of 16. So that's 1 over 4th root of 16 simply means how many number will you multiply by itself? 4 times to give 16. That's 2. 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is 2. 1 over 2. So that's 1 over 2. The third question is quite simple. 3 is power minus 5 divided by 3 is power minus 2. Applying the second law here. I divided two numbers in the index form. So, and they have the same basis. As simply means 3 is power minus 5 minus, because you are dividing, and then minus 2. So take note of that. Then here is for minus 5. And minus plus 2. And comes 3 is for minus 3. And 5 plus 2 is minus 3. Now, let's remove the negative sign. It becomes what? 1 over e raised power 3. It is simply equals 1 over 3 raised power 3 is 3 times 3 times 3. That's 27. 1 over 27. Then the fourth question here is square root of 7. Square root of 7 is power minus 3 over 2. Remember we said square root is what? A fractional power. That is, square root simply means is power 1 over 2. When I say 7 is power 1 over 2, it means square root of 7. Square root of 7 means that means power 1 over 2. Then this is now used to another power outside minus 3 over 2. Remember that law where we said if a number is to 2 powers, what do we do? We simply multiply the 2 powers. This is 7 is for 1 over 2 times minus 3 over 2. That equals what? 7 is power minus 1 times 3, 3. Then 3 times 2, 4. That is power minus 3 over 4. I can start with that. Then the fifth question here is 0.216. 0.216 is power minus 2 over 3. We can see we have a decimal here. Anytime we have a decimal, what you have to put to is to convert it to fraction. Yes. To make it easier to work with. So this is 216 over 1000. Yes, the fraction. E to the power minus 2 over 3. But at the same time, we have a negative fractional index. What you have to do is to first eliminate the negative sign. If you have negative sign now, what do? You simply say 1 over that number. Now, but you can see you already have a fraction here now. Now, take note of this. When we have 1 divided by 2, it simply means what? 1 over 2.